Good morning and welcome. So just how important this topic of innovation in stroke, I think, was recently underscored by looking at Cleveland Clinic's list of top 10 medical trends and innovations in 2019. We made 3 of the 10. Number 2 is the advent of AI in healthcare. Number 3 was expanded window of time for acute stroke intervention. And number 7 was new tools and technologies for pre-hospital stroke diagnosis. So over the last 18 months at Erlanger and Chattanooga, we've launched 2 national AI-based companies, Neuralytics and Viz. We've been very focused on developing these technologies, and we've learned a lot. We've also been working with Epic, developing interface systems. So this is very much in our wheelhouse, and I'd like to share with you some of the lessons learned over the last 18 months. So there's numerous pre-hospital technologies now that are both available and under development, but there's a broader definition about what these pre-hospital technologies are. I think really the proper way to think about this is technologies that facilitate care prior to arrival at the comprehensive center. We have ambulance-based portable LVO detection systems now, which are underdeveloped. We have ambulance-based AI facial recognition systems to diagnose stroke. We have telestroke in ambulances and at the primary stroke centers. We have EMS navigation apps to facilitate directing stroke patients to the most appropriate center. We have electronic data sharing systems linking EMS, primary, and comprehensive centers for pre-hospital notification and in-hospital-based data acquisition, very important. We have advances in EMR itself, like for EMS with ESO, which is designed to download data directly into Epic and other EMR systems. We have mobile stroke units, and we have cloud-based automatic CTA and CTP-based cerebral vessel imaging and communication systems shared between the primary and the comprehensive centers. Obviously, we're not going to get through all of this in 20 minutes, but we're going to hit the highlights. So what's the main problem we face? Well, in the United States, even today, less than 10% of eligible patients for thrombectomy are treated in a timely manner, if at all. So we can learn important lessons from cardiology, who dealt with a very similar problem. In Mission Lifeline, this was the largest quality improvement program in STEMI. What they found was that the major problems really were on the pre-hospital side, on diagnosing, on transferring patients to PCI-capable hospitals, and activating their teams. By monitoring workflow data carefully and mandating new technologies, which at the time were EKGs and ambulances, they were able to improve treatment dramatically. They showed they were able to reduce the percentage of patients that were not treated with lytics or PCI reperfusion. There was a significant increase in the pre-hospital use of EKG, which was shown to improve outcomes. They, most importantly, reduced the median time from first medical contact to PCI. They reduced the door-in and door-out times of the referral centers, and they demonstrated that adjusted mortality rates decreased significantly. This is exactly where we need to go. So in the process of avidly working on developing pre-hospital technologies that will improve patient outcomes, what have we learned? Let me tell you from my perspective. Number 1, we need an EKG-like LVO detection device for EMS that can accurately detect lesions in any artery where we might intervene endovascularly. Secondly, immediate access to all patient data, clinical and imaging, including from EMS, the primary center, and the comprehensive center, and this should feed directly into our EMR. Look what they're doing at Duke. The improved study is exactly what we need to do. They are proposing and moving forward with a data collection system throughout the state of North Carolina to look at all aspects, but that data is hard to get. We need to automate the process. Ideally, our communication systems must be able to handle multiple disease conditions, MI, stroke, trauma, sepsis. Stroke itself is less than 5% of EMS calls or ED evaluations. And lastly, we need CTA and CTP-based technologies for automatically screening for LVO with alert broadcasts and immediately portable access to images so we can look at those images. And we need systems that are built in for immediate communication within the entire team. We are not where we want to be, nor are we going to ever get there in terms of LVO detection based on physical examination alone. I think there's ample evidence of that. The sensitivities and specificities are just not where we are. We want to be much better than that. So let's look at some of the technologies that are developing. So CerebraTech, very interesting, machine learning AI system with multiple antenna array generating 72 data points per scan. We know that different brain pathologies have distinct tissue, electrical, and fluid properties. Electromagnetic waves of different frequencies are emitted, then modified by tissue fluid properties, producing a unique appearance. Using the contralateral hemisphere as the baseline, a greater than 10% asymmetry is thought to predict stroke or intracranial hemorrhage. The initial studies are very promising. The test can be done in 30 seconds, and it's demonstrating sensitivities north of 90%. Brain pulse from Jan Medical. Normally, blood flow in the brain generates asymmetry between the hemispheres. The right ICA is closer than the left to the left ventricle, and it produces an oscillation in the brain, interestingly. The pathology in the brain produces abnormal oscillations and patterns. So in this reusable helmet containing small accelerometer sensors with tips directly on the scalp, a scan takes about 4 minutes and is thought to be able to actually predict large vessel occlusion. They're studying it both in large vessel ischemia as well as in hemorrhagic stroke. So you're going to see these technologies. Whoever is the first one to accurately get on the market and be able to work with good sensitivity, really, I think, is going to hit a home run. Stroke Finder, another LVO detection system, transmits low-energy microwave through the brain. Microwaves scatter within the brain, and the scattered pattern is unique to different pathologies. So again, an AI-based algorithm compares the scatter patterns that are stored and compared to reference values. And this allows them to differentiate between ischemic stroke and ICH, specifically regarding large vessel ischemia. And this too is under investigation. The Lucid robotic system, which is near and dear to our heart, is an autonomous AI-based robotic TCD signal capture system. It has full FDA clearance, and we are now using it widespread through our hospitals and other hospitals for the autonomous TCD data acquisition. This means that we have gotten rid of our ultrasound techs. We don't need the ultrasound tech. What we're working on now is the autonomous LVO recognition ability. So we use the mathematics, not just looking at, say, 4 points along a curve, but in fact, we look at the entire data set from each waveform. And with that, analyzing it with both the flow asymmetry or velocity asymmetry index and the flow curvature index, we can predict not only if there is an LVO, but exactly where that LVO is. Is it in a carotid? Is it in M1? Is it in M2? This is the direction we're going for very fast. We're looking at sensitivities and specificities of 97%, and this is where we need to be. We cannot miss these large vessel occlusions. So this is very promising technology you're going to hear more about. So for widespread adoption of any of these autonomous LVO devices, what do we need? We need excellent sensitivity. Sensitivity is more important than the specificity. We're going to have false positives, and that's okay. But then we need governmental and local approval for diversion. We're going to need a post-marketing study that proves the clinical benefit of using these technologies to change our routing or workflow. And that's going to has to drive to changes in AHA and ACEP guidelines. But it has to be affordable, and there has to be a good business model around these technologies. Who's going to buy it? Who's going to pay for it? What's the reimbursement? So unfortunately, while I want to be very positive about these are big hurdles we need to overcome. And there's a general lack of real strong interest in the investor communities in these technologies at this point. I'm very hopeful that we'll move forward with this, but I am a little bit nervous. Let's talk about the automated imaging analysis systems and the communication systems. We all know Rapid. Rapid is our legacy. In many reasons, it's kind of why we're here. It certainly drove, I think, to a positive SWIFT Prime study. Rapid interfaces with other systems for communication, such as Pulsera and Join. As you know, it is a CT perfusion based technology. And I think you may hear some big announcements about Rapid in the near future, possibly even very, very soon. But with Rapid, what you have is you have now a wonderful app that allows you to look at these images on the CT perfusion side very accurately. They also have now a CTA built into that, so you can upload your CTAs, and they have a very nice viewer. The problem we have is that the vast majority of our centers don't have CTP. Many of your spoke hospitals do have CTP, but across the United States, it's going to be a bit of a heavy lift to get everybody doing CTP. Certainly, they have made tremendous inroads in improving the technology. In addition, you're going to hear more about the e-aspects, which is an automated aspects that will be incorporated into Rapid, and they're making great inroads in terms of volumetric calculations on intracranial hemorrhage. What we really need with Rapid, though, is we need not to be looking at all of these scans that come across a center like ours. We need an automated Lvo recognition system within Rapid, so they will alert us when there's a large vessel. So keep your ears tuned. Viz AI is in fact just that. So it truly is an artificial intelligence, deep learning-based system that actually scans the arteries, particularly the distal ICA and the M1 and the M2 out to the sylvian fissure. And there's 4 different components of the Viz system. There's the Viz View, which is a very impressive mobile app that allows you to have basically a PACS-like system in your hand. You have the automated detection software, which I have to say, I know of only 2 cases at our center in the setting of thousands of scans where they've missed a large vessel occlusion. There's going to be false positives, as the previous speaker talked about, but they have a very, very nice 3D system that allows you to put a point anywhere on the vessel and rotate around that point, and you can see very quickly if it's a false positive LVO. They have the CTP features as well, so you can upload the CTP images, and they have a built-in communication software that allows us to communicate in a very, very unique way. So they've released multiple new products within Viz over the last 6 months. There's group messaging that works very well. You are able to customize the CT perfusion Tmax greater than 6-second windows, very similar to Rapid, and these thresholds are very important. It's another way of detecting LVOs. And we have a very nice system built within Viz to capture all of the clinical data, or much of the clinical data, and they're expanding this rapidly. The 3-dimensional rotational properties, I'd encourage you to look at that because it works very, very well. And of course, this is all wrapped in a very, very tight HIPAA-secure environment. So we don't have time to get into Pulsera and Join and Triage, but these are real-time communication systems that form dedicated patient channels. It allows us to do group messaging, audio clips, images, phone, video calls, and notifications of important events throughout the teams. Some of these are more focused on the pre-hospital side. Join, Pulsera, very much want to expand this, not just from the pre-hospital side, but help us collect data and communicate well into the hospital as well. So I'd like to just end by talking about what the term disruptive really means and showing you an example of what has happened at our center over the last year. With the Viz platform, we now get an immediate LVO, nearly immediate, within just minutes, of if there is an LVO at one of our spoke hospitals. So Hamilton Medical Center in Dalton, Georgia was the first spoke hospital in the United States to have Viz. It is a non-Erlanger hospital that we rolled Viz out to. We have Viz throughout all of the Erlanger hospitals as well. But really within about 4 minutes of a patient having an LVO, when they're still on the scanner, we not only get the alert, we see all the images. So the pathway, which used to be Viz, a patient would come in, they would have a clot, they would get a CAT scan, they would get a CTA, perhaps. In many cases, they wouldn't get a CTA. But eventually, after the radiologist read the scan, after he called the ER, after the ER called us, after we called them back, we would identify the patient with an LVO. In looking at that center, we found that looking at 95 patients, that the average or the median door-in, door-out time for potential mechanical thrombectomy patients was 135 minutes with a standard deviation of 98 minutes. Now our neurologist gets notification immediately, and rather than them calling us, we call back through our transfer center, we talk to the ER doctor. At the same time we're doing that, our interventionalist is seeing the images and has the notification himself. Then our neurologist is calling the interventionalist and discussing with them the patient's potential candidacy. And as a result of identifying it so quickly, our team now is coming in at the same time that the patient is being sent to us in transport. 87-year-old female presented to Hamilton Medical Center with an NIH stroke scale of 22. Viz picked up the clot right here. So let's just walk through the timeline here. CAT scan started at 5:26 p.m. The Viz CTA acquisition ended at 5:30. Our doctor looked at these images on his phone at 5:43, and he texted into the app that there's a distal M1 occlusion 1 minute later. Exactly 1 minute after that, he's calling the transfer center and patched through to the doctor. He beat the Viz LVO alert by 1 minute, okay? If he was not so adamantly looking at his phone, the LVO alert would have gone off, and that would have been the recognition, but he beat it by 1 minute. And he's actually not on call. He's just watching this in the background. Dr. Pidianov, who is on call then, is reviewing the study. Dr. Shaw relays the history to the rest of the team through the app that the patient is a candidate. And as he's talking to the doctor down there and they decide the patient's a candidate, he says, launch the helicopter, because they make the decision that this is an emergency transfer. We fly the patient down there and pick the patient up 60 miles away. I call into the center to get the door-in, door-out time. The bottom line is the patient came in, got a CAT scan, got a CTA, got the LVO alert. We did all the communication. We launched the helicopter, flew the helicopter down there, picked the patient up out of the emergency room. All of that was done in 49 minutes. This, in my mind, will become the new standard of care for stroke treatment. Then, as the patient's flying up, we've already looked at all of the images. So we are talking to our interventional neuro team, and because the patient came so quickly and the aspect looked so good, our interventionalist decided, let's come in. So they're driving in as the patient's coming up. Very, very revolutionary in terms of the change in the workflow. And she lands at our center with an NIH still of 22. TC2B flow is obtained after 2 passes, and on day 3, she goes home with a NIH of 0, and I'm going to play this right here, if I can play this here. Your mouse is where? Can you activate this, please?
Now, I understand that you don't even have to go to rehab. You are going to go home today. Are you excited about that?
I'm excited. Yes,
Wow. So she's going to go home today.
3 days after having a stroke.
That's unbelievable. That's a fantastic story. Okay? Well, God bless you, man. We're glad that you're doing so well. Bye-bye.
She's one of the first people in the world to ever have clot identified and recognized, and her whole care organized around artificial intelligence. So what I want to end with here is whenever you roll out a new technology, you have to build and modify and really think about the process of how you're going to incorporate this technology into the patient workflow and the clinician workflow. So we've been working with Hamilton very closely to develop exactly this workflow, and it's been a very, very interesting process, and it's completely revolutionized, frankly, the way we practice stroke. You're going to see a lot more of this down the road, and I'd be happy to talk to anybody who has an interest in going through this. So as we introduce these new, truly disruptive technologies, the clinical team must understand in detail exactly what impact the technology will have on our clinical workflow and responsibilities as clinicians. So in conclusion, the future is very bright, and the potential of these new technologies to improve patient outcome is incredibly exciting. Companies need our feedback, though, to integrate these technologies and assure that they are designed for maximal benefit and maximal usability. Thank you very much.